Okay, thank you very much. Good evening to all. Uh, this is another presentation today. Thank you very much for giving me the space for talking about this ancient water management in Sri Lanka. Now, yes, when you say water management, we believe that always it's meant for irrigation. But in Sri Lanka, this ancient system, there are a lot of things, not only for food production and irrigation. They use this water for human needs. Then there's another kind of historical evidence to say that they have done very old system, rainwater harvesting. And also they love environment and they wanted to protect environment, flora, fauna, and other parts. Then they use water for city planning, especially Anuradhapura and Sigiriya. Then they made these efforts to make the parks, landscaping, and so many things. Water sprints you can see from Sigiriya fountains. Administrative boundaries also they decided based on the water. Then natural disaster mitigation, flood, drought, cyclone, epidemics. So there are a lot of things. Now, I just want to tell you that they have a very good master plan in ancient Sri Lanka. They have put it at country level, then from river basin to river basin, then even from reservoir to reservoir, there are a lot of giant canals. Even at sub-watershed level, sometimes we call cascades. Then village level and field level. So they have a good master plan. Unfortunately, it has been collapsed after some time due to war and some epidemics, but still there are remnants. Now, for example, here you can see a lot of giant canals. We know that one is from Kalavawa to Tisavawa, Basavakulama, and there are diversion from this main canal to Nachadu, Nuvarava. So many giant canals they have constructed. And also, we can see that there's a very beautiful and specific characteristics that is brought by Yodalo Giant Canal from running from Kalavawa to Tisavawa. You can see that it's a single bank canal. It runs around contour, almost contour. Water is collected from upstream while it is running through this landscape. Then water is released to both sides. Generally, irrigation canal is constructed to distribute water to downstream. But here you can see that there are places where you get water from upstream and again direct to upstream. Then canal moves along tank upstreams because they didn't want to disturb these small tanks. It goes around the tank. And now what we did that we have done some modifications to these giant canals. So it really shortened in 1970s with the accelerated Mahavali program. Now you can see when you go along these canals, all these tanks are sedimented, and those are not productive now at the moment. And also from reservoir to reservoir they have done, especially if you take ancient Anuradhapura system, Anuradhapura city, city gets water from another river basin, Kala Oya, and it feeds Nachadu, Norava, Tisava, Basavakulama, and Bulankulama. So that the city is replenished with groundwater. That is one of the important things that we have to look into. When you visit Ranmasuya, just below Tisava, you will find a good figure there. I just enlarged that, and I am going to see here. It's a stargate. They say stargate. So it's the gate to move to other planets. But when you go through and see, study this and see, it could be the city plan of ancient Anuradhapura kingdom. Now you will find that water cordon around this plan, and there are a lot of other features there. When you compare this one in our old city plan, you will see that there are a lot of similarities. There are entrance gates. Here also there are entrance gates into the inner city. And also water cordon is represented by different reservoirs. So what I wanted to tell you that this inner city is protected with lot of things, and you know that there are water culture evolved in this Anuradhapura kingdom. Water cordon around the kingdom. Tisava, Nuravava, Vasavakulam, and Bulankulam. Focus to enrich groundwater in the kingdom. I am going to suggest you to see that why they wanted to replenish this city with groundwater. Now, when you construct a reservoir, generally we wanted to feed the command areas, but here paddy lands and these tanks are relatively low, and catchments are not adequate, so that they have done their best to feed these tanks from other river basin. Alluvial soil, just around this city, there are two rivers moving there. One is Malatuve, the other one is Helpanwe. So you can expect some alluvial soils there. And how these gigantic structures could be sustained, like Ruvanelsai, Jetwanarami, Abbegiri, and so on these alluvial soils. That is the question that we have. When you take bedrock, you can find two types of rocks like Chanokite genus and granitic gneiss. What we can expect that those groundwater coming from these tanks, which will really pressurize something in the layer, sand layer, and it can sustain these huge structures. Now, these are the rocks that we find there underneath. And there's another evidence that you can see a lot of ponds, wells, and some cordons to protect these palaces. All these are given some kind of features to monitor the water level. You can see that the steps, not only to get down into this one, but there are layers like. So one can monitor the water level. If there's a drop of this water level, they will have to be replenished. Otherwise, groundwater will deplete, and that can be a big hazard. So what I want to tell you that there are cities being sunk due to depletion of groundwater table. For examples, one is Beijing in China by 11 centimeter per year. Then Mexico by 28 centimeter per year. Jakarta in Indonesia by 28 centimeter per year. Bangkok in Thailand by 12 centimeter per year. So those are due to, they found that it's due to groundwater depletion. Now, when you take this world map, you can see a lot of cities now at the moment sinking. So we have to be very careful about this. There are signs. Some vertical cracks now we can observe in Ruvanelsai. 4 cracks in Jetwanarami. Most probably due to groundwater depletion because of the other examples that we can get from other countries. Then there's another map you can see when you put all these big reservoirs, old reservoirs, those are just below this 150-meter MASL. So how they put this, how they plan this, we can't see any kind of instruments or satellite or whatever it is. No technology could be really traced. Then at small scale, there are a lot of clusters of tanks which are feeding water to big reservoirs. So that is why we say that they are so much worried about these floods and drought, so that they had come up with networks of reservoirs to absorb water during rainy season and keep this water for dry seasons. So one of the things that we found that those tanks are organized in clusters. We call tank cascade systems later. And what we have observed recently that it's not only water movement, but also there are a lot of other features organized in these systems. So we had to change our definition from water-based to ecology-based definitions. Now, this is one of the things that we studied at the village level. When we say tank, hamlet, and paddy field, and there are some other Chena lands in the upstream, but we found that that is organized in a very, very scientific manner to keep this water more clean by having sediment trap here, we call Godavala. Then there are two soil ridges either side of this upstream, we call Iswatia, to divert this sediment polluted water, and we get a very clean water. And here we get Perahana, that is filter in a meadow. Then there are some trees, tree belts here, Gascommana, and during flood time, the water can be spilled. And here there is a seepage from these tanks, which will be polluted with a lot of salts, and it can be trapped in this reservation we call Katakadu. There are a lot of things can be explained in this system, but that will ensure the sustainability of this. Even here, the paddy field is, you can see that Godavala, Perahana, Gascommana, and Iswatia, that will make a good kind of controlling devices to make the water unpolluted. Then the other way, that downstream, Katakadu, Gangoda, Isbambe, Huel and Land, they will contribute to feed this vela or paddy lands with a lot of fertility enhancement. And here, when we go back to our ancient kingdoms, one is Sigiriya. A lot of people believe that it's a creation of King Khasya, but it's not true. About 3,000 years ago, before the Prince Kasyapa came into that, this has been constructed. So you can see that there are canals to convey water from top to bottom, like this in Sigiriya. And also there are places like this to create water sprints with some kind of nozzles. When it rains, you can see even now today, there are some kind of sprints coming up. This emerges due to water coming from somewhere else, but not under that much pressure. But you know that we can imagine that the kind of water sprints would have come up about 15 to 20 feet. How they could be able to get the pressure for this sun? That is our question. Now, when you see that the landscape of this, you will find another rock with special features, like not the natural, but there can be some kind of intervention from the community. That is Pidurangala. From Pidurangala to Sigiriya, the direct distance is about 1 kilometer. And we will find the special features of this top of this rock, Vidurangala. You will find convex and concave top planes. So we suspect that these Sigiriakins must have been in need of clean drinking water. They must have tried something rainwater harvesting systems in this Pidurangala. Why we want to tell you that there are some remnants of this clay pipes which can be sealed. And when we trace this one, you can see that the pathway can be like this. So it can be a difference of elevations about more than 100. Yes, more than 100. And you can see the edges are generally inwardly shaped, not the outside, so that the whole water can be collected here. And also there are a lot of large rocks at the bottom of this this mountain, Vidurangala rock. And you can see that the cracks are just perpendicular to the natural decay lines. So that it's not natural, it can be sometime man-made, I should say. And when you take this one, you will see that the whole flow pitch is about 5 acres. And finally, water will be collected here and it will go out. So there are some convex portion of this rock and the concave. We have visited very recently. I can remember that we had a team with Dr. Kamal Laksari, and we found that it's a real innovative work they must have done. They are during the old historical era. And you can see some lines that they have constructed to divert water from the ridge to the bottom. Then there are some other canals we could see on the top of this rock. Those are man-made because otherwise the shape must have been something like this. But here you can see that the edges are sharp. And that can be utilized to divert all this water with some kind of filtering process. And finally, it can come here to concentrate into one point through a water filtering ponds. So finally, it will come here and disappear somewhere here. And there's another balancing stone you can find on the top of this rock. This balancing stone, you can have a small feature here with the like a mirror image of this whole Pidurangala rock top. Like this, you can see the same shape. Like this. So generally our ancestors must have had some kind of mold, stone mold, to prepare the rainwater harvesting model. It is the mirror image of the flow pitch. Why we want to study these and come up with some kind of concepts? Because when you calculate using present rainfall pattern, somebody could have had about 10,000 cubic meters per year, fresh water, without any pollution. If you take this 10,000 meter water, volume of water, what does it mean? Okay, forget about all these as a myth, but when you get 10,000 cubic meters to the people who are living around, sometime you know that at present they are threatened with chronic renal disease, kidney disease. Now what I say that even during rainy period, now you can see this water is flowing, concentrated into this area and flowing like this. So what I suggest that why we are curious about this history, if the daily drinking water requirement is 3 liters per head, that kingdom, the people must have had the opportunity to use this around 9,000 people population. And that is what we need. But there are some other things that I have to tell about ancient water management system. One is that this Maduroya, old sluice. When you see that, you will see some unshaped big stone boards, and those will be fitted into, and there are some air cavities. So why they wanted to have it? The same era, 6th century BC, we find everywhere these prehistoric burial sites. Ibbankatu, Andarawava, Bellankadawala, Yangway, like that. So same kind of shapes we could find. They are in these burial sites and these sluices. So we can consider this as a initial part of in the evolutionary process of this ancient sluice. You can find in third century BC here and 5th century AD. This is Urusitavava and coming to Kalavava. So that there's a evolutionary process must have taken place to get this Bisokotua principle later as a invention of the Sri Lankans. Why we want to study this one? Because there's a big pressure because of the head of this water height, and it has to be dissipated. So they have constructed here pressure releasing chamber. That is the principle of old Bisokotua. Then there are some other small things that to release water from small tanks at the sluice, they must have had some kind of devices. So this is one of these we call Katahorova. Katahorova means piece of these pipes put together like this, organized in a way that one can remove part of that, and this part will cover water mass here, which will really move through this one, and it will feed paddy area. So they must have had some kind of mathematical methods to see that how much the water volume this one pipe piece can release to feed the paddy field. So they have that done, and they have measured this one. You must have heard of this Diyakatapahana. That's a natural rock, man-made rock, which could be, they are labeled at different levels. And when you release this water from Katahorova, so part of the volume will go into that 10 feet. So how we can say that the paddy field is fed enough? So that really they have used one wooden one called Karahan Kote. They put this on log with some cuts like this. So they have different portion of lands to feed in different sizes. For example, here you have 3 different sizes of lands, A1, A2, A3. Then they have to pass this flow in different discharges like Q1, Q2, and Q3. How they could be able to do this? They have changed the depth and the width here and here. So for example, if you take these three outlets from one sluice, when they open the sluice, the water will flow from these three in three different discharges. So once they close the sluice at a time, all these paddy fields are fed, but those are different areas. They have not used any kind of mathematical formula, but they have some kind of scientific way of doing it. So this Karahankote is another example to see the wisdom of our water management system. So what I suggest you to investigate all these, and we'll have to sit together, engineers, water scientists, agriculturists, archaeologists, all together, and see how we can use this cognizance from the past to improve our knowledge, saying that sometime you will find miracles. So those miracles can be explained by using modern science, but see the wisdom that we had in the past invented our ancestors. Those are few things that I wanted to make during a very short period. So thank you very much. And if there's any kind of clarification I make, I am waiting for that. Thank you very much for all. Thanks.
Yeah, thank you very much, Dr. Dharmasena, for this very valuable presentation. I think he has shared a lot of valuable information on how the ancient irrigation management is used to use for human needs, preserving the environment, and mitigating the natural disasters. I think it's very valuable for our younger engineers to get this information which you can't find in textbooks or any other sources. Further this, I think especially the tank cascade systems, river basin canals, cooling reservoirs, and the rainwater housing systems such as Pidurangal, I think those are the very valuable information he has shared with us with a lot of research done to enlighten